A steam trap is a device used to discharge condensate and non-condensable gases with a negligible consumption or loss of live steam. Most steam traps are nothing more than automatic valves. They open, close or modulate automatically. The three important functions of steam traps are: discharge condensate as soon as it is formed. Unless it is desirable to use the sensible heat of the liquid condensate, have a negligible steam consumption. That is, being energy efficient, have the capability of discharging air and other non-condensable gases. Basic operation: the simplest form of steam trap is a disc or short solid pipe nipple with a small hole drilled through it installed at the lowest point of the equipment. Since steam condensate will collect at the lowest point and live steam is about 1200 times greater in volume than this hot liquid, condensate is effectively removed and steam is blocked. However, the vast majority of steam traps in current operation are of the mechanical or thermostatically operated design. Mechanical and thermostatic steam traps basically open when condensate and inert gases need to be removed, and close when all the condensate is removed. The process repeats when new steam is condensed again and ready to be drained. Steam traps work best when sized specifically for the application they are used on. Generally it is better to oversize, as they will still discharge condensate when present and close or obstruct the live steam. However, an oversized steam trap may wear quickly, waste energy, and if drastically oversized can cause process issues. Types: steam traps can be split into four major types. Mechanical traps. They have a float that rises and falls in relation to condensate level, and this usually has a mechanical linkage attached that opens and closes the valve. Mechanical traps operate in direct relationship to condensate levels present in the body of the steam trap. Mechanical steam traps have a typical service of life of 3 years. Inverted bucket and float traps are examples of mechanical traps. Temperature traps. They have a valve that is driven on/off the seat by either expansion/contraction caused by temperature. Differ from mechanical traps in that their design requires them to hold back some condensate waiting for it to cool sufficiently to allow the valve to open. In most circumstances this is not desirable as condensate needs to be removed as soon as it is formed. Thermostatic traps. Thermostatic traps and bimetallic traps are examples of temperature-operated traps. Thermodynamic traps. Thermodynamic traps work on the difference in dynamic response to velocity change in flow of compressible and incompressible fluids. As steam enters, static pressure above the disc forces the disc against the valve seat. The static pressure over a large area overcomes the high inlet pressure of the steam. As the steam starts to condense, the pressure against the disc lessens and the trap cycles. This essentially makes a TD trap a time cycle device. It will open even if there is only steam present. This can cause premature wear. If non-condensable gas is trapped on top of the disc, it can cause the trap to be locked shut. Venturi nozzle traps. Venturi nozzle steam traps work by utilizing the basic physics of two-phase flow for the effective removal of condensate from steam systems. Steam and condensate pass through the Venturi nozzle steam traps by a series of staged steps. The denser liquid throttles the Venturi nozzle, which keeps the steam from escaping. Erosive eddy currents are eliminated and any contamination is carried away with the condensate. Because condensate is created continuously in a working steam system, the condensate continuously chokes the nozzle from losing steam as condensate is removed continuously. Venturi nozzle traps require expert engineering and precise sizing in steam systems. External links: Understanding Steam Traps, American Institute of Chemical Engineers, Steam Trapping, an Overview, Spirax Sarco Limited. How Steam Traps Work, Clam Engineering. Steam Basics, Armstrong International, Incorporated. Steam Trap Types, U.S. Department of Energy Federal Energy Management Program, Broken Link. What types of steam traps can you insulate? Wehrmacht jackets, The History of Steam Traps, TLV International, Incorporated. What you need to know about Venturi orifice steam traps, Thermal Energy International. http://www.steamgrid.com